All right, so we're talking about something called piecewise functions. A piecewise function is a function that is defined by two or more different functions for different parts of the domain. Okay, it's defined by two or more different functions for different parts of the domain. So instead of just having the absolute value of x plus 3 from negative infinity to positive infinity, we're going to split it up. Okay, we're going to split up our domain. So you can see what a piecewise function looks like here. We'll talk a little bit more about this later, but piecewise functions are actually very realistic. Okay, if you're one of those people that loves to ask, when am I ever going to use this? A lot of situations in real life are defined by a piecewise function. You can't just apply one function to the entire situation. You have to break it up. It depends on what you're talking about. For example, gym memberships. A lot of times they will offer those. You can pay per month if you're not planning on going every single month of the year, or you could pay for an entire year. So it depends on how many months you're interested in doing it. Another classic example of a piecewise function is the tax bracket. Okay, I know y'all don't pay taxes, so you're not really familiar with this idea, but your parents pay taxes at different rates based on what interval their income falls within. If they don't make very much money, then they don't pay as much taxes as somebody who makes money in a higher range. They pay more taxes. So that's an example of a piecewise function. So let's start with the easy stuff. Let's just evaluate these piecewise functions. Let's look at that first example. We've got f of x, our function, is defined as the quadratic function x squared minus 1 if the x values are less than negative 2. So any x value less than negative 2, negative 10, negative 3, negative 100, anything that's less than negative 2, you use the function x squared minus 1. If it's greater than or equal to negative 2, so negative 2, negative 1, 0, 0.5, 8/3, whatever it may be, greater than negative 2, greater than or equal to negative 2, then you use 5x plus 3, the linear function. So if we're asked what is f of negative 5, we've got to figure out, okay, which piece does that apply to? Is negative 5 less than negative 2, or is it greater than negative 2? Less than. So we plug that into the first piece, negative 5 squared minus 1. So negative 5 squared is 25. 25 minus 1 is 24. We do not plug it into both pieces. You figure out which piece it fits into, and you plug it into that one. Okay, f of negative 2. Is that less than negative 2, or is it greater than or equal to negative 2? Greater than or equal to negative 2. So we plug negative 2 into the second piece. 5 times negative 2 plus 3. So that's negative 10 plus 3, which is negative 7. Again, you're more than welcome to use your calculator. I encourage you to practice some mental math. All right, f of 7. Plug it into the first piece or the second piece? Second piece. 7 is greater than negative 2, so we also plug this one in the second piece. So we've got 35 plus 3, which is 38. Okay, questions so far? Pretty simple, right? Okay, we can have more than one piece. Okay, we can have more than 2 pieces. We can have 3 pieces. Usually we're not going to deal with more than 3 pieces, but it is possible to have more than 3 pieces. So we've got when x is less than or equal to negative 4, when x is between -4 and 1, and when x is greater than 1. So g of 2, where does 2 fit into our inequalities there? The first, second, or third piece? The third piece. 2 is greater than or equal to 1, so we plug that into the third piece. 2 times 2 cubed plus 9. So 2 cubed is 8. 2 times 8 plus 9, that's 16 plus 9, that's 25. All right, -1. Which piece does that fit into? First, second, or third? Second. -1 is between -4 and +1. Now, be careful with this. That second piece already has a negative in front of the x. So that's what we need to do. You got to put the negative and your number in parentheses and then the -1. So -1 is +1. +1 minus 1 is 0. All right, and then finally, -6.
Seniors P through T report to computer lab. Seniors P through T report to computer lab. And sophomores I through P report to computer lab.
All right, -6. -6 is less than -4. So we plug that into the first piece. So we get -3 plus 3. It also gives us a value of 0. It also gives us a value of 0. All right, questions? Okay, now this is not on your paper, but I need you to add it either there on the side or somewhere. Okay, what if I give you the kind of this combination idea? I'm not just asking you what is f of -5 or what is g of 2, but I want you to put some pieces together here. I want you to find 3 times f of 0 minus g of -6 plus 3 times g of -2. And that's what we're going to do. Okay, we're going to find these values just like we did before, but then we're going to do this linear combination here. We're going to put them together and we're going to multiply them by some multiples. So let's do these pieces by themselves first. Okay, let's find f of 0. Let's find g of -6. Let's find g of -2. I'm going to start with the g's because I don't have to scroll my page if I do that. So g of -6. -6, we already found that one, right? We already found g of -6. It's equal to 0. G of -2. Now we didn't do g of -2. -2 fits into the second piece. So -2 minus 1. So that's +2 minus 1. So it's equal to 1. And f of 0, we didn't find it, so let's see here. Is 0 less than -2 or greater than -2? Greater. So we plug it into the second piece. 5 times 0 is 0, plus 3 is 3. All right, so I found f of 0, g of -6, g of -2. Now let's put them together with this combination that it wants. It wants 3 times my f of 0. My f of 0 was 3, so 3 times 3, minus my g of -6 value, well, that was 0, plus 3 times my g of -2, that was 1. So we've got 3 times 3 is 9, minus 0, it's not going to do anything, so plus 3 times 1 is 3. So that this whole answer is 12. All right. Questions? Okay. Now, the next section is talking about graphing. Talk about graphing. It says graph each piecewise function, then identify the domain and range. Here is how I approach the graphing. Because yes, You can plug, in this case, the first function is x. You can plug that in your calculator and you can graph it, but you cannot make that calculator, there are some calculators that you can make do it, but you cannot make that calculator graph the piecewise function, okay? If you type in y equals x and you type in y equals negative 2x plus 1, you're just going to end up with two lines that are graphed entirely. It's not going to cut them off where it's supposed to cut it off. So you have to do this by hand. Here's what you do. You are going to, I know some of y'all like steps, so step 1 is plug in the changing point. Okay, the changing point is that value with the inequality. So in this case, it's negative 3. Plug in the changing point to the first piece. And plot. All right, so when we plug our changing point, this one, it changes where x equals negative 3. So if we plug negative 3 into the first piece is just x. So when you plug in negative 3, you get negative 3. So on our graph, we are going to find the point, negative 3, and we're going to plot it. Now this was equal to negative 3, so we are going to put a point right there. We are going to put a point right there. Now, if you're good at graphing things by hand, once you have that point, and if it's a linear equation like this one is, then you can just use your slope and you can graph the rest of it. Okay, obviously you have a slope of positive 1, so we go down 1, left 1, because we have to go to the left. It's less than negative 3, so it's the left, less than left. Okay, if you're not comfortable with trying to apply the slope, then plug in at least one number to the left of the changing point. So in this case, negative 4 is to the left of negative 3. If I plug that in, I get a y value of negative 4. So I plot the point, negative 4, negative 4. I could do it for as many points as I want to, whatever it takes for you to be comfortable to graph that line. Okay? But that is all we are going to graph of the line y equals x. We only graph it until we get to the x value of negative 3. To the right of negative 3, where x is greater than negative 3, greater ends in an r, means to the right, our graph looks like negative 2x plus 1. So the next step is we're going to plug our changing point into the second piece. Pretty much we're just repeating steps 1 and 2 with the second piece. Okay, so when we plug that into this one, we've got negative 2 times negative 3 plus 1, so that's 6 plus 1, that's 7. So we plot the point negative 3, 7, but it didn't say that it was equal to negative 3. So we're not going to put a point, we're going to put an open circle. So x equals negative 3, y equals 7. We're going to put an open point. I know it's kind of hard to tell here with mine. My point here is a little thick. Here we go. Okay, make sure you have an open circle there. Make sure that I can tell the difference between an open circle and a closed point. Okay, I'm going to repeat step 2. with the second piece. So this time I'm picking a number to the right of -3. Now, what would be the easiest number to the right of -3 to plug into our equation? What's usually like the easiest number ever to plug into an equation? 0. And 0 usually pretty easy to plug into an equation. Is 0 to the right of -3? Yes. So how about we do that? Plug in 0. What do we get? 1. Notice that's also our y-intercept. This one crosses the y-axis. Okay. Or you can use your slope. You can use your slope of -2. Just sometimes using the slope gets people into trouble because they have a hard time with the positive and the negative, depending on what side of the function they're supposed to be graphing. Okay. So that's what the graph of this piecewise function should look like. There's a change at x equals -3. Okay, you should be able to draw a line or put your pencil there at x equals -3, and to the left of it, it should look like one function, in this case x, and to the right of it, it should look like the other function, -2x plus 1. Okay, let's talk about the domain and range here for a second, okay, because it can get a little tricky. Okay, the domain, moving left to right, we hit all the x values. Okay, we don't have any missing values here, so this one does have a domain of all real numbers, so -infinity to positive infinity. Let's talk about the range. Bottom to top. Okay, range, we always go bottom to top. We start here at the bottom of the graph. Okay, we've got graph, we've got graph, we've got graph, we've got graph, until we get up here and it stops. Okay, our maximum value here, so we started at the bottom, we started at -infinity, we go up, we go up, we go up, we hit our maximum of 7, but we don't actually equal 7 because we have that open circle there. So 7 gets a parenthesis instead of a bracket. If that were a closed point up there, it would have a bracket. If that were a closed point up at the top, we would have a bracket. But it's not a closed point, it's an open circle, so it's a parenthesis. All right, questions? Let's do another. And number 4, -3x minus 7 if x is less than -1, and -5 if x is greater than or equal to -1. So we plug in our changing point into the first piece and we're going to plot it. So -1, when we plug that in, -3 times -1 minus 7. So that's 3 minus 7, that's -4. So we are plotting the point -1, -4, but it did not have the equal to, so that's got to be an open circle. At -1, -4. -1, -4 gets an open circle. Now, this piece says less than, so we're going to pick a value to the left of -1. What do y'all want to plug in to the left of -1? -2 sounds good to me. -3 times -2 minus 7. You could have plugged in -3. You could have plugged in -4. Okay, just it's easy. Pick one that's a little bit closer. All right, so -3 times -2 is 6. 6 minus 7 is -1. So the point -2, -1. We're going to plot that. If you got 2 points, you can draw a line, right? Now that I know which direction it's going in, I like to use my slope of -3 so that I get a little bit more accuracy here. All right, So that's the left side. That is to the left of -1.
Sophomores who would like to have your picture made, Q through Z, report to the media center. Seniors, P through T, report to the media center. Computer lab.
All right, second piece. It's equal to -5 if the x value is greater than or equal to -1. So it's always equal to -5. So I've got a point at -5, point at -5, point at -5. It's always -5 when my x values are greater than -1. This had the equal to, so we put a point at -1, -5. But then we're always equal to -5 for x values to the right of -1. Okay? Questions about the graph? So the domain here, okay, left to right, we're not missing anything. Okay, yes, there's a little jump in the graph right there, but we still have a value at -1. So the domain for this is -infinity to infinity. Let's look at the range. Start bottom to top. We don't have anything until we get to -5. So we've got -5, but we just have -5. Okay, so we're just going to put it in its own little bracket. And then at -4, we have an open circle. So we put a parenthesis with -4. And then we're going up to positive infinity from there. We go -4 all the way up and we keep going. So that range is a little weird. That is a weird kind of range there. All right, we're going to skip 5 and 6 because I'm going to let y'all do those. Let's look at 7. Let's look at one that has 3 pieces. Okay, we've got 2x when x is less than or equal to 2. We've got -1 minus x when x is between -2 and 4. And we've got -3 when x is greater than 4. So let's start with the very first piece. Plug in -2. 2 times -2 is -4. So we've got the point, -2, -4. It was equal to, so we put a point there at -2, -4. Pick a number less than -2. Why not go with -3? So 2 times -3 is -6. So -3, -6 is another point. So I've got 2 points. I can draw my line to the left. Okay, we're going to the left. Now, when we have that piece in the middle, we're going to plug in both changing points that they give us. We're going to plug in the -2, we're going to plug in the 4, and then we're going to graph the line in between those. So when we plug in -2, I'm going to do it over here, -1 minus -2, subtracting a negative, same as adding a positive, -1 plus 2 is 1. So -2, +1, open circle, because we're not equal to -2 there. We're not equal to -2. Plug in the other changing point. 4. -1 minus 4 is -5. So 4, -5 also gets an open circle because we were not equal to 4 there. And we've got the endpoints of this middle piece, so just connect them. If you are a perfectionist like me, there is a short little ruler in the pencil box there if you want to use that to draw your lines. All right, last piece. If x is greater than or equal to 4, the y value is -3, always. So start at 4, -3. It is equal to, here, so we put a point, and then we're always equal to -3 to the right. X is greater, R right. All right, domain, no issues, so it's -infinity to infinity. As we move left to right, we always have some graph, and that's how you decide that. So look at the range, start at the bottom. We've got value at the bottom, so that means we start with -infinity. Okay, as we're coming up, we have graph, 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 until we get up there to 1, and it's an open circle, so it gets a parenthesis. If it were a point, then it would have a graph. Okay, do we feel like we've got it, or do you want to see one more? One more? Let's do number 8. We're changing it 0, we're changing it 6. So plug 0 into the first piece. -3 times 0 is 0. So 0, 0. Oh, not a point, it's a circle, because we're not equal to. Open circle at 0, 0. I'm exaggerating mine so you can see it. Yours doesn't have to be that big. Just trying to exaggerate. All right. Value to the left, x is less than 0. Give me a number that's less than 0 to plug in. -2. So -3 times -2 is 6. So -2 is what we plugged in. So that's our x. We got out 6. So we got a point. Slope is 3, so I'm going to fill in a middle point here so I can draw my line a little straighter. No, try to. Okay, so that's what the first piece looks like. To the left, it's less than 0, so to the left of x equals 0, that's what our graph looks like. Okay, between 0 and 6, we've got -1/2 x minus 1, so plug in 0. So we get -1, 0, -1. It is equal to 0, so 0, -1 gets a point. Plug in the other endpoint. Plug in 6. -1/2 times 6 minus 1, so that's -3 minus 1, that's -4. So we plugged in 6, -4. It's not equal to 6, so this is going to be an open circle. So 6, -4. Open circle, connect those two right there. That's the middle piece. Last piece, plug in the changing point, plug in 6. 6 minus 7 is -1. Open circle, 6, -1. Plug in 7. 7 minus 7 is 0. So that's what the last piece looks like. To the right, x is greater than 6. To the right of 6, it looks like that. All right, domain. Going left to right. We're good, we're good, we're good. Check out what happens at 6. Neither one of these inequalities said x equals 6. We don't have a value where x equals 6. So this domain we need to split up from -infinity to 6, parentheses, because we don't equal 6, and then we pick right back up right after 6. Okay, remember, we've done some like this before, and I know it looks weird. It looks like, well, why can't I just squish those together? That notation right there says that x never equals 6. It does not have a value at 6. It has a value as close as we can get to 6 over here on the left side of 6. It has a value as close as we can get to 6 over here on the right. Okay, 5.99.
Any junior or sophomore that has not had your picture taken, report to the media center. Seniors, U through Z, report to the computer lab.
Okay, what I was saying was 5.99 5.99999999, I plug that into what? The middle piece. It has a value. 6.00000001, I plug that into the third piece, because that's just greater than 6. So as close as I can get to it, but I can't actually equal 6 for this piecewise function. All right, range, bottom to top. Okay, we don't have anything until we get to that -4, but we don't actually equal the -4, so it has a parenthesis. See what happens. We've got graph, we've got graph, we've got graph. It picks back up over here on the right side. So we hit all the y values from -4 up until positive infinity. Okay, there were no gaps there in the y values. There is a little gap right here, but look over here. Those y values get covered. So that's why that's okay. All right. I know the domain and range is a little tricky. Really, what I'm more focused on is evaluating and graphing. Okay. Don't get hung up on the domain and range. Focus on the evaluating and graphing.